Okay, so we're doing question 1 part D today. In this question, we need to use mathematical induction to prove that the sum of the first n multiples of 8 is equal to 4n times n plus 1 for all natural numbers n. Let Pn represent the statement we want to prove. That is that the sum of the first n multiples of 8 is equal to 4n times n plus 1. And we must show two things. We must show that P1 is true. This is typically called the base case. And we must show that for all natural numbers n, Pn implies Pn plus 1 is true. This is typically called the inductive step. Once we show that the base case and the inductive step hold, we'd be able to conclude that Pn is true for all natural numbers n. So let's get started. For the base case, put n equal 1 in the statement for Pn, and we get that 8 is equal to 4 times 1 times 1 plus 1, which is equal to 4 times 1 times 2, which is equal to 8. Since 8 is obviously equal to 8, we can conclude that P1 is true. For the inductive step, let n be an arbitrary natural number and assume that Pn is true. That is, assume that the sum of the first n multiples of 8 is equal to 4n times n plus 1. This assumption is typically called the inductive hypothesis. The goal is to show that Pn plus 1 is true. That is, to show that the sum of the first n plus 1 multiples of 8 is equal to 4 times n plus 1 times n plus 2. Well, the sum of the first n plus 1 multiples of 8 can be grouped into the sum of the first n multiples of 8 and the n plus 1th multiple of 8. From the inductive hypothesis, that is from the assumption that we just made, we know that the sum of the first n terms is equal to 4n times n plus 1. And then in the next step, I just factorize the second term, that is 8 times n plus 1 into 4 times 2 times n plus 1, so that we can clearly see what the factors in common between the two terms are. In this case, the factors in common are 4 and n plus 1, so factorizing, we end up with the expression 4 times n plus 1 times n plus 2, which is what we wanted to prove, so therefore we can conclude that Pn plus 1 is true. Since we've shown that both the base case and the inductive step is true, it follows that Pn is true for all natural numbers n. This completes the proof and the question. Hey guys, Dwayne here. If you're a Caribbean student struggling with Pure Maths and you need extra help, then go to this link to join my free study group. Also, don't forget to subscribe to this channel and click the notification icon to get notified when I upload new videos. Thanks for watching and see you next time.